Hello, my name is Manav. This is Unit 2A, Lesson 3 of Algebra 1 Honors or Integrated Math 1 Honors. This is writing linear equations, graphs, slopes, and y-intercept, as well as solving for y. So just as a review, a linear function is a function represented by a straight line on a graph. To remember, we have line, which means a straight line, and then function, which means that for every x value, it has a different y value. And this is something that can be found in a graph. So it may look like this, it could look like this. There's different variants that you can find of a linear function. But the two main things that you have to keep in mind is that it must be a straight line with no disturbances in the middle, and it must be a function, which means that the x cannot repeat with different y values. So I'm going to talk about the components of a linear equation. This means that if you were to go into a calculator, which is most commonly used Desmos, and you go onto Desmos graphing calculator and you type in an equation in this format, you will graph a straight line. And you can try that out on your own. But just as a heads up, go to Desmos and go to Graphing Calculator and then type in any equation that we talk about in this video and you will see a straight linear line. So the equation that was most common is going to be y equals mx plus b. Y is the y value of a coordinate, m is your slope, x is your x value of the same coordinate, and b is your y-intercept. And a y-intercept is when the value of y is the value of y when the line intersects the y-axis, also when x equals 0. So for example, if this one, your y-intercept is right here, for this one, your y-intercept would be right here, assuming that this is the origin right here. So this is known as slope-intercept form, and that is really important to remember because there are two forms of linear equations. There's this one where you have y equals mx plus b, and that's very common, and that's going to be slope-intercept form. There's another version, so make sure that you understand the differences between the two. But remember, it's y equals mx plus b. Y is the y value of the coordinate, x is the x value of the coordinate, m is your slope, and b is your y-intercept. Make sure that you memorize m and b. Now, what is slope? So if you don't understand slope, I strongly suggest checking out my previous video where I talk about slope. It's the rise over run, it's the change in y over change in x. But slope measures the steepness of a line. It's known as rise over run or change in x over change in y. Again, check out the previous video if you need a more in-depth explanation. And here are the four types of slope we can have. We can have positive, which means that slope is going upwards, negative, meaning slope is going downwards, 0, which means it's a straight line, and undefined means it goes vertical. And undefined, keep in mind that it's not a function. So if you have an undefined slope, it's not a function. 0 slope means that the slope is a straight line. So just be careful about that. 0 slope does not mean no slope. No slope is undefined. 0 slope means that the value of slope is 0. So for an example of positive slope would be y equals 2x plus 4 because the number 2 is positive. Similarly, the number negative 2 is negative. Here, we don't have a slope because we do not have an mx, we just have a b right here. And this, keep in mind that it is x. If you were to go into Desmos and graph in x equals 2, your line would look like that. If you were to go and type it in on Desmos for y equals 2, it would look like this. Y equals negative 2x plus 4, it would look like that. And y equals 2x plus 4 would look like this. So hopefully this makes sense. This is pretty self-explanatory. The two hard ones are 0 slope and undefined slope. Undefined slope, the line is vertical, it is straight up and down, and it usually has x equals. 0 slope means that we don't have a slope. So in the equation y equals mx plus b, there is no mx, it's just b. All right, moving on, I'm going to talk about what y-intercept is. Well, y-intercept is when the line of the graph crosses the y-axis, or also when x equals 0 if that doesn't make sense. So for example, we have an equation y equals 5x plus 7. Y equals mx plus b. So 5 is m, 7 is b. So one way we can do is we can set x to 0. So if we replace x with 0, we get y equals 5 times 0 plus 7, which then moves us on to y equals 0 plus 7, because that is 0. 0 plus 7 is 7, so y equals 7. And remember, x is 0 and y is 7, and y is the y value of a coordinate. So our y-intercept is going to be 0, 7. Y-intercept occurs when x equals 0, and x-intercept occurs when y equals 0. So because x is equal to 0, we're finding our y-intercept when we solve this equation out. Instead of actually doing math, you can also just remember that b is your y-intercept. So that means that this number is your y-intercept. So you already know your y-intercept, and y-intercept occurs when x equals 0. So please keep in mind that y-intercept occurs when x equals 0. Again, y-intercept occurs when x equals 0. And in order to find y-intercept, either you can set x equal to 0, which is more math, or you can just look at the number and remember that x is 0. But the main thing to remember here is that x equals 0 for the y-intercept. Okay, moving on, we have how to graph an equation onto a graph. So the four main steps are to plot your y-intercept first, then is to translate your slope into rise over run form, and then you're going to rise from your y-intercept the rise number, and then you're going to run from your new place the run number. So I have the example y equals 2x plus 4 that we used earlier. The first step would be to graph our y-intercept. It is 4, so our y is 4, and remember y-intercept occurs when x equals 0, so we have 0, 4, which is right here. Next, we're translating to rise over run form. We know that any solid number is essentially just that solid number over 1. So our rise is 2, and our run is 1. Next, we're going to rise 2 places from our y-intercept, and then we're going to run 2 places from we're going to run 1 place from the new location. So first, as I show here, we rise 1, 2. Remember that there is a 5 here. And then that's rising, and now we run 1, which leaves us at this new point, which is 1, 6. Next, we just draw the line, a straight line down, that crosses this point and that point. All right, hopefully that makes sense. And lastly, how do we take a line and translate it into slope-intercept form? The first step would be to find the y-intercept and set it equal to b. Then we rise over run, we identify that and set it equal to m, and then we write our equation using y equals mx plus b, replacing the values for m and b. M and b will always be the same for this specific equation. X and y will always be the same for all equations in the future, no matter what. You will always have a y and an x in your equations. And if you have 0 slope, where it's just y equals something, remember that it's 0x, and in math, you try to be as simple as possible, and 0x is just 0 times any number which is 0. So that's why instead of writing 0x plus a number, they just don't write 0x, because it's 0. There's nothing there. Okay, first, this is our line, and we identify that our y-intercept occurs when x equals 0. X equals 0 here, so y equals 4. And since that number is 4, 4 equals the y-intercept equals b equals 4, and that's right here. Next up, we're going to rise and run to our next point. We rise 1, 2, we rise 2, and we run 1, 2, 3, 4, 5, 6. Remember that the scale of the graph is in 2, so it's actually like this. So that's why I'm counting by 6, even if it looks like I'm not counting by 6. So we rise by 2, that's right here, and then we run by 6 right here. And in case you do not remember, 2 6 can be simplified to 1/3, because you can divide both sides by 2. 2 divided by 2 is 1, 6 divided by 2 is 3. This gives us our slope. Our rise over run is our slope, and slope is m. So now we rewrite in y equals mx plus b. So y and x are given, they're always the same. Our b is 4, so that's here, and our m is 1/3, which is right here. So the solution for this line is y equals 1/3 xo plus 4. Now, lastly, we have solving for y. In the occasion where an equation is not in slope-intercept form, you can translate it to slope-intercept form by solving for y. If you don't know what translating expressions are, I strongly suggest checking out my previous video about that you can be found in Unit 1. Just double check that. That goes way into depth about how to translate. But essentially what we have to do is we have to change this form so that it's just y on one side. And that's what I'm going to explain to you. So we have our familiar slope-intercept form, and then we have another form you may find something in. It's going to be a number x plus ay equals b. Again, these are just numbers. So I'll show an example where you actually use real numbers. So we've got 4x plus 2y equals 8. We need to isolate y. So we need to deal with the things that are farthest away from y, which happens to be 4x. So as you see here, we subtract 4x to both sides. Because 8 does not have an x, you cannot combine the two. So they have to be separate. So they can only be connected together with a sign, which is plus or minus. In this case, it's plus because 8 is positive. It doesn't have a negative sign, which means that it's automatically positive. When we rewrite our equation, we rewrite with the x's on the left, the closest to the equation sign. So we rewrite as 2y equals 4x plus 8. Then we have to deal with the numbers that are directly touching y. Right here is multiplication, because 2 times y is the same thing as 2y. And so we're going to do the opposite, which is division, to all 3 terms. You have to treat each one individually. So 2y divided by 2 is just regular y, negative 4 divided by 2 is negative 2, and 8 divided by 2 is 4. That leaves us with y equals negative 2x plus 4. So essentially, 4x plus 2y equals 8 is equal to y equals negative 2x plus 4. These two are the same things. If you were to type both of them into Desmos, you would get the same line. Now let's practice everything that I've talked about. First, I'm going to go with identifying the different types of slope. The 4 types are positive, negative, zero slope, and then an undefined slope. So our negative slope occurs when we have a minus in the slope, which is right here. So this is negative slope. Here, remember that zero slope occurs when we do not have mx. So right here, we have just b. b equals 0. We do not have mx. So this is going to be zero slope because we have no slope. Do not get confused. Now, if this was a 1, it's still zero slope because we don't have a zero. We don't have any slope. Our slope is equal to 0. Next, we have this one. It has x. So x is an undefined slope. There's no slope. And lastly, we have y equals 7x. This is a positive because it doesn't have a negative sign. So this is positive slope. So again, the hard ones are zero slope and undefined slope because they're very easy to mix up, as many people get mixed up with zero because they think that if the equation looks like this, they think it's undefined because you can't have stuff equal to 0, but no, it's zero slope. Undefined is when you have x equals. So undefined x equals 0 is y equals with no slope. So just as a safety measure, if you have y equals and then no x on one side, that's zero slope. If you have x equals and no y at all, that's undefined. Okay, now let's practice finding the y-intercept. Remember, the y-intercept is equal to b, and this is our equation. So this number over here is going to be our y-intercept. So that would be this, that, and that. But remember, y-intercept occurs when x equals 0. So we have to set x equal to 0 in all 3. Add a comma so we understand it's a coordinate point, and then just plug in the numbers. Now we're going to draw a line on our graph. Our equation is y equals 1x plus 2. The first step is to plot our y-intercept. Remember, y-intercept occurs when x equals 0. So we go to when x equals 0, and we just go to 0, 2, which happens to be right here. The y-intercept is this line right here. So that's why when x equals 0, we have a point that's on the y. So that's why it crosses at this point. Hopefully that makes sense. Now we have our rise over run, which happens to be 1 over 1. So that means that we go up by 1, and then we go to the right by 1, leaving us at this point. Now we can do this as many times as we want. So we can go up by 1, I'm not gonna do that, and then we can go to the right by 1. I don't like how it did that. So now we can just draw a line that connects all of these points together. It's going to look somewhat like this. So this is the graph of the line for y equals 1x plus 2. If we were to go onto Desmos, we would get a line that looks pretty similar to this. Now lastly, we have to identify the equation from a graph. First is to identify our y-intercept. Our y-intercept occurs when x equals 0. So I'm just going to draw a line straight down and see where we intersect. That is right here. So b is equal to -4. I'm going to rewrite that down here. -4, y equals, and we have to identify mx. Now we're going to rise, and then we're going to run. Now here is where it does get tricky. I'm going to erase this so we have less clutter. But as you can see, we go 1. As you can see, our point is here, but this is also a point on our graph. So instead of jumping up so many times, we can just jump up to here. So let's go ahead and do that. We go 1, 2. So we rise by 2. And now we run. We're running. Normally we run to the right, but this time we're running to the left. And I want you to take a notice at something. If we jump from here to here, we are adding 1. So if we jump backwards, we're subtracting by 1, which means that if we're going to the left, it's negative. So as you can see here, we go -1, -2. So we go up by +2, and we go down by -2. So our rise over run is 2 over -2. 2 over -2 is equal to -1. So our slope, our m, is -1. If we were to rewrite, remember that y and x are always in every equation unless you have 0 slope, which we don't. Then we have to add our b, which is -1, and nope. Then we have to add our b, which is negative 4, and we have to add our slope, which is negative 1. We don't need to write the 1, so we can just write negative x. So this graph of the line, so if you were to go into Desmos and type this in, you would get y equals negative x minus 4. Lastly, we're going to create this equation and translate it into slope-intercept form. First is to deal with all the numbers farthest away from the y, which happens to be that. The opposite of being positive is being negative, so we're going to make 8x negative, which is adding a negative sign to both sides. So negative 8x, negative 8x. This crosses out, and we add this here. Remember, our x is going to be the closest to the equation sign, so leaving us with 3y equals negative 8x. And because 4 is positive, we add positive 4. Next, we're going to do the inverse of multiplication, which is happening right here, to all three numbers. So this is a 3, divide by 3, divide by 3, divide by 3. This leaves us with y equals, and now here's a new thing that we have not seen before. But if you look closely, this and that, it looks like rise over run. So this means that we can rewrite this as negative 8 over 3 as this is our rise and this is our run. And then we just tack on an x. So negative 8x divided by 3 turns into negative 8 over 3. Think of it that we are not dividing the 3 by the x, we're just dividing the 3 by the 8. And then lastly, this one might confuse you, but it is acceptable to have fractions in math. So this just turns into plus 4 over 3. So the equation that we translate would be y equals negative 8 over 3x plus 4 over 3. And just an update, I just want to make sure that you understand what a y-intercept is. So essentially, if we plot any point along this line right here, that's because x equals 0. And that's something you should learn when you're first introduced to the coordinate plane. This means that if there's ever a point here, that point, no matter what line it's on, the coordinate is going to be 0 and then whatever number your y-intercept is. And it's called a y-intercept because that's when the line of the graph will eventually intercept that point, the y-axis. It's called the y-intercept because that's at the point where you intercept the y-axis. So hopefully that clears up what a y-intercept actually is. And thank you so much for sticking around until the end of the video, and I hope that this was informative for you. This was Unit 2A, Lesson 3 of Algebra 1 Honors or Integrated Math 1 Honors, writing linear equations, graphs, slope, y-intercept, and solving for y. Thank you.